So this is a quick review video to overview everything that we've learned so far in Chapter 9. To start things off, we talked about graphing quadratic functions. The standard form of a quadratic function is ax squared plus bx plus c, usually that's equal to y. The axis of symmetry, or the line that divides our parabola in half, is negative b over 2a. And our vertex will give us a minimum or maximum depending on if it's the highest point of our parabola or the lowest point of our parabola. There won't be many examples on this video, but I thought it would be helpful for us to go ahead and do an example of graphing a parabola. To start off, we want to find our axis of symmetry, so that is negative b over 2a. So that would be negative 4 over 2 times 1/2. 2 over 1 times 1/2 multiplied straight across is 2 over 2. So that's negative 4 over 1, which is just negative 4. So that means that on our table, negative 4, negative 3, negative 2, then we also want to go down 2. Remember, your middle x value is always on that line of symmetry. So let's plug in the numbers and get some more points here. We will plug in 1/2 times negative 4 squared is 16. Actually, you know what? I'm going to go ahead and write that down. Probably shouldn't skip that step just in case we missed that. So again, 1/2 times negative 4 squared plus 4 times negative 4 plus 1. So negative 4 times negative 4 is 16. 1/2 of 16 is 8. Negative or positive 4 times negative 4 is negative 16 plus 1. That gives us 8 minus 16 plus 1. That gives us negative 8 plus 1, which would be negative 7. Now again, you can go either direction. I'm going to go ahead and I'll just move down. 1/2 times negative 3 squared plus 4 times negative 3 plus 1. Negative 3 times negative 3 is 9, so that'll be 9 over 2. 9 over 2 is 4.5. 4.5 minus 12 plus 1. That gives us negative 7.5 plus 1, which would be negative 6.5. And if 1 to the right is negative 6.5, 1 to the left in our graph will also be negative 6.5. Continuing on, 1/2 times negative 2 squared plus 4 times negative 2 plus 1. 1/2 times 4 is going to be 2 minus 8 plus 1, and that is negative 6 plus 1, which is negative 5. And again, if 2 to the right of our graph is negative 5, 2 to the left of our graph will also be negative 5. So let's go ahead and plot those points. I'm going to take this graph just because it's small, and I'm going to count by 2s. 2, 4, 6, 8, 10, and I'm going to count by 2s in all directions. So negative 6, negative 5, that'll be negative 2, 4, 6. Negative 2, 4, and 5 would be halfway in between. Negative 5, negative 6.5. 2, 4, halfway would be 5. 2, 4, 6, and a little bit to give me 6.5. Negative 4, negative 7. 2, 4, 2, 4, 6, 7. Negative 3 to 3, negative 6.5. And negative 2, negative 5. Finally, we draw our line through. And remember, this is supposed to make a parabola shape, so a U, not an absolute value shape like a V. Important things to remember is your vertex, or the point on the hump, is at 2, 4, negative 4, negative 7. Now, because this is the lowest point of my graph, it forms a minimum. So other things to review over that we'll be doing is solving quadratic equations. That's when we have a quadratic equation. Typically, we'll set it equal to 0. And here are when you use which method. You use a square root if the equation has no x term and you're only looking at x squared equals 9 or something like that. You use factoring when you can easily factor the equation. You use completing the square when the coefficient of your x squared term is 1, but it's not easily factorable. And then you use the quadratic formula if the equation cannot be factored easily or even at all. So let's remember our quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And we plug those in from our quadratic equation that we're given. The discriminant is just the part on the inside, the b squared minus 4ac. Anytime your discriminant is greater than 0, you will have two solutions. If your discriminant equals 0, you will have one solution. And if your discriminant is less than 0, you will have no solutions. We also talked about the difference of linear, quadratic, and exponential functions. Our linear graphs looked like lines. Our quadratic graphs look like parabolas. And our exponential graphs look like slides. For a table, we are always adding or subtracting by the same number. In quadratics, we are adding or subtracting and then adding and subtracting again, and we have the same second difference. So linear is same first difference. Quadratic is same second difference. And in our exponential functions, we were multiplying by a common ratio. That was when we were looking at our tables. Linear functions were y equals mx plus b. Remember, that's slope-intercept form. Quadratic functions, y equals ax squared plus bx plus c. And our exponential functions were y equals a times b to the x power. Finally, solving systems of linear and quadratic equations, we had three methods: graphing, which we usually use just to estimate; elimination, where you have to line them up, subtract out a variable; and substitution, where you replace one variable for the other. So I know that this video didn't have very many examples. I just hope it was good for review and in preparation of our review day. To end this, I have a really great joke. It's my favorite joke. My favorite animals in the world are hippos. They're really cool. I think I told you the story about the hippo who ate a car. If I didn't, ask me to tell it, but I know I did. But here is my joke in honor of hippos. Why don't you ever see hippopotamus hiding in trees? Well, because they're really good at it, duh.